Hi, this is Alfozia Nihar from At Home Tuition. Welcome to our session today. The topic that we are going to discuss in our today's video is inverse function. Hope you all are clear about what is a function, when a relation is a function. In case if you have any query regarding that topic, you can refer our previous videos. Now in this video, we are going to focus on inverse functions. First, we will start with the notation. The inverse of a function f is denoted by f inverse, this symbol, and it is pronounced as f inverse. Although the inverse of a function looks like you're raising the function to be negative 1 power. Am I right? But actually it is not. And the inverse of a function does not mean the reciprocal of a function. If you are a new learner about this topic, there are chances for you to get confused with this notation. So please be clear that inverse function is denoted by f with an exponent negative 1. Actually this is not an exponent. It should be pronounced as f inverse. Hope you're clear with the notation? Okay, now let us discuss detailedly about the inverses. Generally, a function normally tells you what y is if you know what x is. Am I right? Same way, the inverse of a function will tell you what x had to be to get that value of y. Hope you're clear with the statement? Okay. A function f inverse is the inverse of f if there are two conditions. Let me let you know. For every x in the domain of f, f inverse of f of x should be equal to x. Same way, for every x in the domain of f inverse, f of f inverse of x should be equal to x. Hope you're clear with these two conditions. Generally, you can say this: the domain of f is the range of f inverse, and range of f is the domain of f inverse. Hope you're clear with this point? Okay. Now let us see the graph of the inverse function. You will understand these concepts once we discuss some examples. Graph of the inverse function is very simple. The inverse of a function differs from the function in that all the x coordinates and y coordinates have to be switched. For example, 4, 6 is a point on the graph of the function. I'm taking a rough example. Then 6, 4 is a point on the graph of the inverse function. The x and y coordinates has to be switched. Hope you remember the point that we just discussed. The domain of the function f is the range of the inverse function. Range of the function f is the domain of the f inverse. Am I right? That is this point. Points on the identity function y equal to x. This will remain on the identity function when switched. All other points will have their coordinates switched and move the locations. Hope you're clear with this point? The graph of the function and its inverses are mirror images of each other. So this point will help you to remember the graph of the inverse function. They are reflected about the identity function y equal to x. You can just draw a line here and fold the paper like this. So it will look like a mirror image of each other. Am I right? So this is all about the graph of the inverse function. Now let us discuss about the existence of an inverse function. You have to check whether an inverse function exists or not. There are also cases where the inverse functions does not exist for some condition. Not all the functions will have inverse functions. A function says that for every x there is exactly one y. Am I right? That is, y values can be duplicated but x values cannot be repeated. If the function has an inverse that is also a function, then there can only be one y for every x. Am I right? A one-to-one function. One-to-one function means a function in which for every x there is exactly one y, and for every y there is exactly one x. So a one-to-one function has an inverse that is also a function. There are functions which have inverses that are not functions. You have to note this point carefully. There are also inverses for relations. For the most part, we disregard these and deal only with the functions whose inverses are also functions. You may not get many questions which like functions that don't have inverse. So if the inverse of a function is also a function, then the inverse relation must pass a vertical line test. You have to note this point too. So you can check for the vertical line test. Since all the x coordinates and y coordinates are switched when finding the inverse, saying that the inverse must pass a vertical line test is the same as saying the original function must pass a horizontal line test. Hope you're clear with this point? Okay, if a function passes both the vertical line test and horizontal line test, I mean vertical line test, if it clears, then it is a function in the first place. If it clears the horizontal line test so that its inverse is a function, then the function is one-to-one and also it has an inverse function. So this is how you have to check the existence of an inverse function. In case if it does not pass the vertical line test and horizontal line test, you can say that there does not exist any inverse for that function. So far we discussed what is the notation, graph and existence of the inverse function. Now let us see how to find the inverses step by step. First, let me know if there is any query regarding the previous part of this video in the comment section. Now let us start with the example. First, I'm going to start with how to find the inverses informally. The inverse of some functions, especially those where there is only one occurrence of the independent variable, can be solved by undoing the operations. To undo the operations, you must not only reverse the order, but you have to use the inverse operation. So I'm taking an example. F of x is equal to 5x minus 2. So let's start with this. Okay, we have to start with x. I'm going to isolate x on one side of the equation. So if you look at this equation, you can understand that x is multiplied by 5 and subtracted by 2. So inverse of this would look like this, doing the opposite operations. If 5 is multiplied with x, you should divide it by 5. 2 is subtracted, so you should add 2 with x. So this is how we find the inverses informally. Finding the inverses informally means you just have to undo the operations. You must not only reverse the order, you have to use the inverse operation. Okay. Let me explain you how to find the inverses formally. Here we have to follow certain steps that would be very clear and easy to follow. Here are the steps. We have to start with the function. So now in the previous example, we just undo the operation. Here there is another way that does not rely so much on informality, and we will work whether or not we can figure out exactly what we did with exactly 1x. So here are the steps. Start with the function, replace f of x by y if necessary, and you have to switch the x and y's. So this is the important step. So at this point you're dealing with the inverse and you have to solve for y algebraically. You have to follow the same steps what we follow in algebra for solving for some term. So replace y with f inverse of x. If the inverse is also a function, you have to otherwise leave it as y. These are the basic steps. So let me take an example and explain you how to follow these steps and find the inverse. Here is an example. F of x is x square over x square plus 1 and x is greater than or equal to 0. So the restriction here is we have to make the function one-to-one. Okay, I'm going to start with the function f of x. F of x is equal to x square over x square plus 1 under the condition x is greater than or equal to 0. Now I'm going to replace f of x by y. That is your first step. And next step is to switch x and y's. So I'm going to change y as x and all x as y's. Now we have to solve for y. So how can we do this? Multiply the denominator. Multiply both the sides of the equation by y square plus 1. Normal algebraic calculation. Now we are going to distribute x y square x times 1. Now we are going to group all the y's to one side of the equation and shift this x to the other side of the equation. So subtract y square from both the sides and subtract x from both the sides of the equation. Now let us factor y square. Y square is common for both the terms. So I'm taking y square as a common factor outside and writing all the leftovers within a parenthesis. So to isolate y, what we have to do, you have to get rid of this coefficient. So just divide both the sides by x minus 1. We need to solve for y. So I want to get rid of this exponent 2. So I'm going to take square root on both these sides. Hope you're clear till this step. Since y is greater than or equal to 0, we need to take the positive square root only. So y would be equal to, so call this as f inverse of x. That's it for this example. Hope you're clear with all the steps. The steps are very simple. All you have to do is switch x and y and solve for y. That's it for this. Sometimes the instructions say if the function is not one-to-one, then you don't find the inverse function because there is not one. So always check before wasting time trying to find the inverse function. Hope you're clear with this concept inverse function. In case if you come across any difficult example or any questions, kindly let me know. We can have a discussion on that too. Hope you're clear with all the points that we discussed in this video. In case if you have any query regarding this topic, kindly let me know. See you in the next